All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. Spiro, I see that you are indeed first. Good to see you. Ross Void, good to see you as well. How's it going? All right. So, let me just make sure that the feed is good on both sides. Looks like it is. The bitrate's good. Okay. Pete's Astrophotography over on the YouTube side. How's it going? Good to see you as well. All right. So, tonight we've got a little bit something different on the roster. We are going to be taking a look at, or I should say, doing a retrospective of the entire game engine project from start to finish, and taking a look at some of the things that worked, some of the things that didn't work, and so forth. And so that's kind of what I have here on the screen. We're going to kind of step through that a little bit, and then we're going to make a list of action items and things that we need to do to move forward with the project. There are some items that I do want to tackle in the actual game engine before we continue too much further with the game. So you'll note that this episode is actually named after the engine series. So this is sort of an extra little entry in that series, and we're going to talk about that as well. But before we do that, I do want to just take a quick second to thank the supporters of the channel, beginning with our elite partner, Javier Olazaron. That is the highest tier of subscription over on YouTube memberships and Patreon. Followed by our partners, who is the next tier of support over there. They are Gerboles Inc. and Matt Osgard. Followed, of course, by the rest of our supporters, who are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you guys very much for being here and the support, of course. That is going to offset the financial costs of running this channel, the hosting costs, software licenses, asset fees, things like that. So that is very much appreciated. And of course, I wouldn't be anywhere on this channel or on the project without all of you guys, the viewers, whether you're joining us here live on the Twitch side or the YouTube side. We do simulcast to both. So thank you guys for being here. I appreciate you guys. Okay. So let me just catch up on chat. Lexi, how's it going? Good to see you. Ross, it's 3 a.m. where you are. You just woke up. Where are you? 3 a.m. That's got to be. That's got to be what in the European, one of the European time zones, right? I'm guessing. All right. So, Norway. Okay. All right. So I was not very far off there. Perfect. Well, thank you for tuning in. All right. So, today we're going to talk a little bit, we're going to do a little bit of a retrospective, and we're going to start off with some stats, because this project's been going for a while. So I'll just kind of keep this website here in the background for the project. But so if we want to take some quick statistics down here, the first commit for this was actually made on February 28th, 2021. So this project's been going for over 4 years now, which is crazy to think about. So as of the 0.9 branch, which has not yet been released, we'll get to that in a second, there have been 472 commits. Most of those being made by myself, a few by the community. There are 77 and a half thousand lines of code so far. And we have 263 full episodes of the Game Engine series alone, saying nothing about the game development with that, just the Game Engine series. Plus some additional ones in between, like patch videos and things like that. So this is the 264th episode, or technically 265th episode, because it did start at 0. And so actually, this is actually kind of off by one. So we've got that. So that's some statistics, right? I just figured that might be interesting to kind of think about, right? And so I guess we'll cover the sort of the good and the bad, and I'm gonna categorize this into the good and the not so good, right? So one of the good things is, I think, is that we have most of our systems are fairly well organized. So we've got a decent setup with our renderer front end, back end, our audio front end, back end. A lot of our additional systems that we put in place very early on haven't really needed to be touched very much. So things like our memory system, our event system, stuff like that really hasn't been touched since the very beginning. Our cross-platform support is pretty stable. So it's pretty stable on Windows, Linux, and Mac. And so I'm pretty happy about that. Those layers are pretty stable as well. Again, we haven't really had to touch those in much of a way, except I think the last thing we added to that was maybe file watchers. And that was quite a while ago, right? And so those are pretty stable to the point where we're not really going to have to do much more with those. The Vulkan render is coming along nicely, right? So we've got a decent support of features implemented with that, and just the engine in general. And so I'm actually fairly happy with how the Vulkan render is coming along. We've got a little bit of things to do in terms of adding a few more features to it, but for the most part, it's really just adding features to it. There's not really any sort of refactoring or anything needed at the Vulkan layer. It's pretty stable. We have a decent amount of features implemented. So if we actually take a look at our to-do list, we obviously have a whole bunch of stuff here to do. But if we scroll past this stuff, so from here on down is mostly checked off, right? So I'm just going to kind of scroll through this quick so you guys can see all the stuff we've implemented. Now there's still some to-dos in here, right? But there's quite a lot that we've actually built. And so, this is sort of where we started breaking it up by release and things like that, right? So, it's come quite a far way from where we started. And for all intents and purposes, we could build a game with it as it stands right now, using version 0.9. And that was my initial plan. However, there are a couple things that I was thinking about we should probably address at some point. And then I got thinking about, well, if we get too far into the development of the game, maybe it might be harder to address those things when we actually have to change our game code, to be able to handle those updates. So what we're actually going to take a look at is some of the things that need to be addressed. And we're just going to go ahead and address them, right? So us just having started developing the game has already, kind of revealed some things that we need to fix. And so that is kind of what we're going to be taking a look at least tonight. This is not an exhaustive list of things, by the way. More than likely, when we're done with this conversation, and even afterwards, I'm probably going to have some time to think about this. I'll probably wind up actually writing an article and putting it up on my website. Just as sort of a touch point that we can easily go back to and read. So those are the things I could think of off the top of my head that are good, without going into every single little detail, right? And so I'm pretty happy with most of that, as far as the good, right? I'm sure there's some stuff in here that's missing, but those are the big points. And then we have the not so good, right? And by the not so good, what we're really talking about here is, this is an educational series, right? So there was lots of things that we were going to try to see how they worked out. Some of those things would work, some of those things didn't work. And we're going to talk through some of those things here tonight. So, these points here were mostly things that we tried to see how it would work. And there are things that need a little bit more attention. And some of this we've already given some attention to, and some of these we haven't. And so we're going to, kind of step through these one by one and kind of come up with an action plan for those. So the first thing on this list is the render graph. So the render graph is kind of this this system that we put into place. Let's see, if we go here to app config, it's a system that we put into place where we can where we can configure how our renderer works in our application config, right? So, we've got all these different nodes that can have different dependencies on one another, and, we can tie them together in different ways, and it's pretty open-ended and pretty configurable, right? And this is all good stuff, right? Overall, I'm pretty pleased with the way that this render graph came out. I think it was a cool idea. I think it was a cool thing to try out. However, adding things to this, does require a fair amount of work, and it does incur a fair amount of overhead when we're actually using this stuff. And so I got thinking about it, and I'm like, and this is going to be a little bit of a recurring theme. There's a few things in the engine that I think we made too generic, and I think this is one of those things. I think this is great. I think the render graph system is awesome, but I think it's overkill for what we need, right? So the game that we're going to be making is going to be fairly straightforward in how it's rendered, and I think anybody that's going to want to make use of this engine is probably going to want to use some fairly straightforward rendering techniques. And so I don't think we actually need this level of flexibility. And the other thing that this level of flexibility adds, of course, is, like I said, overhead. And it's overhead in terms of code, so it's a lot to think about when you're adding features to this or adding additional render graph nodes. It's actual physical performance overhead in terms of extra stuff that has to run. And the dependencies between them aren't always 100% clear, right? And maybe that's a design flaw of the system, and that's okay. I accept that. But it's not necessarily something that I think we're going to need going forward. So the render graph system is actually going to be going away. We are going to do away with it. But since it is checked in, it will be a part of 0.9 forevermore. So we are going to take this out, and we are essentially going to go back to the sort of old school way of just having a very procedural render technique or render list of commands, right? And what I mean by that is we're going to leave it up to the game code to call the renderer and do what it needs to do with the renderer, right? That's going to be a lot more, technically it's going to be a lot more flexible than this without having to set up all this configuration, all this other stuff. So we are going to be removing the render graph. That's going to go. It was a cool concept, cool experiment. I liked it a lot. It does technically work just fine, but I think for this engine and the projects that are going to use it, I think it makes a lot more sense to just have the game code call the renderer as it needs to and step through that, right? And that's going to be a little bit of a theme as well that we're going to talk about tonight. So that's the render graph. The scene is the next thing, right? So the scene, we've kind of talked about this a couple of times on stream when we're talking about the game, and it's kind of rearing its ugly head again, right? So the scene is okay for what it is right now. It works technically, but I think we can do better. We have there's a lot of complexity in terms of like managing the objects, and when I say that, I mean getting a reference to a node or getting a reference to an attachment, and being able to update various properties of that through the node, selecting an object, and things like just things along that nature. It's just not very easy to use. And the other thing is it's not very extensible the way we have it now, and we've already talked about that as well. So the hierarchy is kind of complicated to use. The X-form system is kind of complicated to use, and I'm not really happy with either one. Again, this was something that we kind of tried out, and that we don't. I don't think that this was particularly a success. The render graph, I think, was a success. I don't think the scene was necessarily on that same level. And then you'll see here, I've also got a note here that it's leaning a little bit too much in this whole ECS direction, which I'm also not really fond of. And so we're going to rethink the scene entirely. And by that, I mean, we're going to think about the responsibility of the engine versus the game. And this is going to feed back into that same scenario where I think it makes a lot more sense for the game to determine how these things should run. And so, generally speaking, if you think about the actual data, you think about the actual problem, and you reason about what is happening, there's going to generally be game specific, right? So, you might have one type of game that needs to render the scene in a top down view and has very specific requirements for that. You might have another game that, maybe needs a first or third person perspective that's zoned and split up, right? You might have an open world game that has a completely different set of requirements in terms of how objects are loaded, non-loaded, etc., right? And so I think at this point, it doesn't really make sense for us to say the engine should be handling this. I think it makes more sense for us to say this is something that we really ought to move off to the game code and let the game code determine, first of all, if we even use a scene to begin with, which was kind of the initial concept, but also, let the game code be responsible for how things are rendered, how things are updated, because the game is going to have that context. The engine kind of can't, right? And so we're going to be eliminating scenes as we know them now, and we are going to come up with a very game-specific way of handling scenes instead. And I've gone back and forth on this, thought about a few different formats and things, and ways to make this generic and extensible. And then I got thinking about, the actual problem, and it's like, well, the more generic and extensible we make it, the more complicated it makes it. Whereas if we focus on it from a game perspective instead of trying to make it super generic, and we write it as part of the game, then we don't have to make it super generic, right? We can make it specific to the game, specific to the type of data that we're dealing with, and we don't have to have all of that extensibility and all of the complexity that comes with that, right? So we're going to rethink scenes as well. And so more than likely what we're going to do is we're going to wind up ripping scenes out entirely and building something brand new in game code. Okay, so there's that. And then the next thing I want to talk about briefly is asset and resource systems. Now, we did a lot of work on this last year. And in fact, we were in refactor mode for this quite a lot last year. So there's not a whole lot I want to address here. But there are a couple things. It is much, much better than it was, right? So I still consider this a success. But we still need more work here, right? So the process of actually making a request for an asset or a resource it's pretty verbose, right? There's a lot of code that you have to write. You've got to fill out a structure that has a lot of different requirements in it. And it's just not as easy to use as it probably should be. We also have, this sort of separation between assets and resources, which isn't all that well defined in terms of game code. And so I want to kind of rethink about the resource half of this, right? I think the asset half of it is okay for now, for the most part. There's a couple minor things I want to change there too. But I do want to rethink about some of the way that resource stuff is handled. So I think we have a little bit more work here to do. And then one thing I wanted to mention also about the asset system is the asset system doesn't immediately return a pointer to an asset like the resource system does. And so we have no easy way to say, okay, we are loading this asset, but here's a pointer to it so that you can check. So you've at least got a reference to it. Even if it's not able to be used yet, you've at least got a reference to it, right? And we did that with the resource system, but we did not do that with the asset system. So that's just something we need to address there. So we are going to be revisiting the asset and resource systems and rethinking that a little bit to see if we can't simplify that a bit. And then we also have some systems that don't serve much purpose and really could be and should be removed. And I'm looking namely at the lighting system for this one. So the lighting system, and you may not even be familiar with this because of how little we've actually talked about it, because it doesn't really do a whole heck of a lot. So it is in here in runtime, right? And we have a series of systems in here that actually probably are going to wind up going. So we have this light system here, right, which basically just tracks literally directional and endpoint lights, and that's it, right? That's all. That's literally all it does. Now these things don't need any sort of update loop. They don't need any sort of, um, any sort of management really to speak of. All you really do is create it and you add it to the system, you register it essentially, and you remove it, and that's about it, right? So, systems like this, I was planning on initially doing a lot more with it. This is probably going to wind up going away. So the light system is one of those things. Let's see. There was another one in here. I think the timeline system might actually wind up being another one of those things, because I don't think this is going to quite work out the way that I initially talked about it. So it's not really being heavily used. It's being used in a couple places right now, but I think we can replace it with something better. And then there was also the camera system, which is also not really used all that much, right? So I think we can replace those things safely with something else or nothing at all, frankly. Let's see. Thank you for the follows, by the way. I appreciate those. Is this for retro? So this is a retrospective of the game engine that we've built, right? So we're kind of just loosely talking through some of the pain points that have come up in terms of the game engine as we've started to actually use it to make a game, right? So we've got some major things that we want to address here. And these are the major things I can think of now. Obviously, we're going to add to this list. But in terms of usability, these are really where it's at. So these first two are probably going to be on the majority of the work, right? This one is going to be lightning fast to do. I'm not really too worried about that one. And then the asset resource system is going to be a little bit of work, but I'm not really too worried about that one either. So I do want to, kind of mention that these are all separated out for a reason, right? So we could just say, let's take a couple months, refactor all of these at once, do it all under one branch as we did before, and then realize it was huge and it winds up taking much longer before we can actually cut a release. I don't want to do that. So we're going to talk about where we want to go from here, right? And I'm going to scroll this up so we can see it. And so what we're going to do first is we're going to close off version 0.9, which is the version that we're working right now. So we're going to complete that. We're going to cut a release, and we're going to say version 0.9 is the last version that's going to include a lot of these things as they are. And then we're going to enter several small refactoring stages. And we're going to separate all of these out with complete design discussions where we design this stuff on stream, right? We come up with the actual new design that we're going to use. I'm going to try to avoid doing too much of the design work off camera, right? We're going to kind of talk through that stuff on stream. And then we've got some version numbers here where we're going to address these things directly. And then we're going to get back to kind of our regular to-do list of some of the other features we want to add in. So the first thing I think I'm actually going to tackle is probably the minor rework of the asset resource system to improve the API usability, right? Just to make that whole thing a little bit easier to use. Even if we don't wind up doing all of the changes for that, I do want to make it a little bit easier to use. And we do want to talk about a little bit about assets versus resources and how those things might work going forward. And so that's going to be version 0.10 is going to focus on that and only that. Once we're done with that, we're going to cut that off there, cut a new release, and ship that, right? The next thing is going to be either the scene refactor or the render graph removal. It's going to be one of those or the other. I don't know which one I'm going to do first. So 11 is going to be one of them, 12 is going to be the other, right? So those will be separate releases between those two things as well. And then we also want to have another small release to remove some of the legacy systems. So like we were talking about lighting system, camera system, etc. Right? And then maybe incorporate a few small features. You know, we'll start adding some things back. And then 0.14 is when we're going to add animated meshes. So we don't have that yet. And 0.14 is what I have slated to add those animated meshes. Once we are at a point where we are here, I think we can actually jump back fully into the game, right? So more than likely what's going to happen is we're going to perform these updates one at a time. We're going to have to update our game code. So we are going to be stepping back and forth between the game and the engine, right? But we're still going to be kind of a little engine heavy for a while, and that's okay. So we are going to be kind of stepping back and forth between that. Probably until we get really about, past this point. So all of this, we're going to be kind of stepping back and forth. And then once we're past 0.14, we will probably, 0.15 will be where we actually start adding some of the other to-do items, aside from animated meshes, to the engine. Okay, so that is kind of the retrospective as it is now. At least as I have it, right? So I'm obviously going to do a lot more thinking. Let me just format this real quick to condense it. I'm going to do a lot more thinking about this over the next couple weeks, and anything else that I kind of think about and identify as a pain point, we will be working into these. But this is our plan going forward, and I don't have necessarily date ranges for these. But I don't want any of these versions to last to go more than say 2 months each, right? Some of them probably won't take 2 months, right? Some of them may just take a couple weeks. Some of them might be done in a week. Who knows? But I think the render graph removal is going to be a decent one. The scene refactor is going to be a decent one too, decent sized. I think the rework of the asset resources, I'm not exactly sure how large that's going to be, but I'm going to kind of try to keep scope creep away from it. So that is the retrospective for now. And so now we're going to kind of just jump into start talking about design changes that we're going to make for 0.10. Let's see. Diamond, good to see you. How are you doing? Seeing you over on the YouTube side, good to see you. Is it Elpsy Streams? Or Elsci Streams? I'm not sure how to pronounce that, but good to see you over there on the YouTube side. I hope you're doing well. I probably butchered your name. Sorry about that. Let's see. Good, working on my own renderer rework myself. Awesome. So the good news is we are not going to have to do a renderer rework, right? Our renderer API, I'm actually pretty happy with. There are a couple of things I might add to it for, usability, just kind of convenience functions and that kind of thing. But in terms of how it actually works, I'm actually pretty pleased with it. So I don't anticipate much, if any, render work will have to be done here. It's mostly the systems surrounding that. I love the beard. Good evening. I appreciate that. Thank you. Yeah, it's doing okay. It's doing all right. I like it. I don't think it's gonna get any longer than this though. I feel like it's probably just not gonna get any longer. I don't know though. Time will tell. I'm probably gonna wind up getting really tired of it and like removing it at some point. But for now, I'm enjoying it. I think when high summer comes and it's like 40 degrees Celsius outside, I'm going to want to remove it probably. Had implemented one that was very coupled with everything while I tried to figure out what API I actually want. Refactoring now to make it nicer to use and maintain. Yeah, we went through some of that here as well too. For sure. All right. So, this retrospective document, by the way, is being maintained in the Kohi submodule already. So, We have that as well. All right, so let me think. Status. I think. I guess we don't have any. Interesting. It's saying that it has. Wait a minute. Am I in the right? What is this casein file here? World casein. I think that was something that I was doing offline. In here. Yeah. And I don't think it has. Yeah. I think I can actually throw all of this out. I'm not gonna wind up using any of this. Let's just delete that. We are going to design that in real time instead. All right. So we'll go ahead and leave the retrospective notes. We're not going to check that in, right? We have. Let's see. I think the last thing we had was an asset handler bug fix, and then we add some math stuff. Yeah, so a lot of this. A lot of 0.9 was actually splitting out to be used in a submodule. Boy, there's a lot of stuff in here. Okay, here is release 0.8. So, let's go ahead and make sure this is pushed first off. I don't think there's anything missing. Let me see. Where is the... let's go to... Let's go to 0.9. And I forget, actually... Yeah, I need to actually... Yeah, let's open up a pull request, and let's actually get this merged. So this has got 20 commits in it. So let's go ahead and see if there's anything I want to do before this. No, I think let's go ahead and create a new one. So we want to put 0.9 to main. So yeah, that's all the various stuff there. I think this is because I moved a bunch of stuff around that this change set is so huge. So I'm good with that as it is. I'm gonna go ahead and create this. 85K additions, yeah. Yeah, and the thing is, though, it's not accurate because I moved a bunch of stuff around and renamed a bunch of stuff. So it's like additions, but not really. Looks good to me, exactly. So yeah, we're just going to do this just for traceability, right? Bypass. Spiro, thank you for the gift sub. I appreciate that. Oh, 20 gift subs. Thank you so much, man. I really appreciate that support. You didn't have to do that, Spiro. Thank you. Holy crap, my dude. You just put the hype train all the way to level 5. Yeah, if you guys managed to get a gift sub from Spiro, please toss him a thank you. I really appreciate that support, dude. You didn't have to do that. Thank you. He's going ham today? Yeah. Yeah, apparently. Sheesh. Much appreciated, my dude. Okay. So, I'm not going to delete the branch. That is merged. Salute. Thank you, sir. I appreciate that. I really do. That means a lot. That's going to be a big help too, for sure. Okay, so let me think. That totally threw me off. What was I doing? Okay, I created I merged in 9.0 or 0.9 rather. So now I need to do, I guess really I need to just create a new branch based off of that, right? So retrospectives. Oh, you know what? This was also probably a huge reason for the I forgot that we created Overdrive 2069 and we scaffolded that game project as part of the Kohi codebase. We need to get that out of there. I guess I'll remove it in 0.10. Okay, so git checkout B release 0.10. And then git push u origin release version 0.10.0. All right. So now we have 0.10. So now we can actually start thinking about how we want to do how we want to handle our asset resource stuff. You just read OneDrive? Yeah. Yeah, OneDrive is, I have some OneDrive files somewhere. Yeah, so API usability when it comes to assets and resources. Let's see, where can I think of the most egregious example of this? I think actually, didn't we had something in our game code. So it was in Illumina main. When we go to read in our item DB, which is what we had added in the last stream, this is what it requires to actually load up an asset, which is kind of poopy, right? Like, I feel like we can do a lot better than this. And there's a few issues with this as well that we should probably eventually talk about and see if we can't figure out a better way to do it that makes this a little bit easier to use. So one of these issues is, well, there's this, and then there's also the issue of requesting a resource, which I think, let's see, do we not have, not in that file apparently. Okay, resource, or I guess I'll do resource system request, right? So if we take a look at, let's see, what's a good example here? I guess we could use testbed main as an example, right? So this is how we're loading a scene file, for example, using the current scenes, right? And so this is actually kind of 2 layers deep, right? We have, we have this sort of API for loading in an asset, right? And this is for loading in a resource. Now, just a quick reminder, an asset is basically something that is read off disk, right? So it's the on-disk representation of a resource, essentially. Whereas the resource itself is something that is used in the game world, is uploaded to the GPU, or is played as a sound, or what have you, right? So the example I always use for this is we have an image, like a JPEG or a PNG or a bitmap, something like that, is an image asset, right? And that can be used as a texture resource, right? So that's the difference there. And so the reason that that separation exists is because a image asset, for example, could be used as a texture resource, or it could also be used to generate a height map terrain resource, right? And so there's multiple images or multiple uses for assets potentially. And so we don't necessarily want to tie its on-disk representation to how it's going to be used in the game. So we have this separation that exists that I feel like makes sense. But the problem with that is, like I said, it is very verbose, right? So in order to, in this case, load up a scene, we have to fill out this request info, right? And then within the request info, we also have to provide asset info that is then used to essentially, under the hood, make one or multiple of these asset requests, right? And so essentially what happens is you make this resource request. This resource request reaches out to the asset system and says, hey, I need these assets to fulfill the loading of this particular resource. And then that particular resource can provide a callback when it's actually requested in order to let us know when that resource is ready to go. Systematically, that works fine, but this is a pain in the butt, right? It's just not the way. It's not the way that we necessarily want to work for this, right? If we're loading a resource of some kind. Generally speaking, we want to just say, hey, I want to load, like for a texture, for example, I want to load a texture, use this particular image asset name, as your asset to be loaded, right? I don't want to have to fill all this out. And to be fair, our texture system does handle that for us and abstracts that away, and that's fine. But I feel like this could be a lot simpler to use. Let me see. Oh, there's a hype chest. I gotta do a emote. That's pretty sweet. Thank you again for that, Spear. I really, really appreciate that, man. Top 5 best plugins for NeoVim. Top 5? Telescope's definitely one of them. Mason's another one. You know what? In fact, I'm going to do this. So I actually wrote an article on my website that gives a list of all the plugins that I use. So it's going to be that entire list, basically. You can pick any 5 from there and probably be good to go. Snacks Picker as a telescope replacement. I have not tried that one. Is it supposed to be more lightweight or something? Clicks link, holy flashbang. Yeah, it is a flashbang. Because I didn't write it with all these fancy libraries and stuff that auto-detect your theme. Let me see. I will pull that up and take a look at it offline. Thank you for the suggestion. Supposed to be faster and lightweight. Yeah, okay. I haven't really had too much of an issue with Telescope, so I will look into it anyways, though. I've debated switching to NeoVim because I'm getting sick of VS and all of its quirks. Oh, is it VS or is it actually VS that you're using? Either way, there's lots of quirks in weight. Yeah, I mean, like once I the only thing that I ever use this other one for is debugging, right? But like Spiro. Spiro gifted, oh my goodness. Spiro just gifted 50 tier 1 subs. Thank you so much. You don't have to do that, my dude. I really appreciate it. You really don't have to do that, man. I appreciate the hell out of it. You know that. My goodness, man. Holy crap. I don't even know what to say. I don't even know what to say. Thank you for that. I really, really, really appreciate that. Yeah, thank you. I'm speechless now. Thank you for the follow. Don't worry, just keep going. Yeah. Okay. I'm gonna. Where even was I with that? Yeah, I think we were talking about NeoVim, right? So yeah, I kind of switched to NeoVim a while back. And then like, as far as like any other IDE goes, like I just kind of.
I said forget about it, cuz.
That. Basically. Yeah, that was for you, Spiro. Let's see. Trying to get used to NeoVim ecosystem, but I'm so used to OG Vim. Yeah, that was me for a while too. Not gonna lie. Been using it for 6 years. Yeah, for me it's been 3, maybe. Used Vim beforehand. Yeah, that was me for a long time too. And then I switched to NeoVim for Lua, essentially. Because it's a lot easier to configure. Been using NeoVim for a year and you don't even know Lua. I mean, that's fair enough. I actually have some scripted bits in my config, so. VS struggles with syntax highlighting, and I'm usually left ignoring errors that may or may not actually exist. Yeah. I started running into those issues all the way back on, like, I want to say it was like VS 2012. It was the first time I really remember seeing that hardcore. VS Code has tree sitter now, I think. Oh, I messed up. I didn't bleep it out. I forgot to. I said VS without bleeping it out. Whoops. Got him. Yep. Ugh. Yep. Banned myself for that one. Fail. All right. It's over. End the stream. Yeah, exactly. Don't need all the AI stuff, fancy features. Yeah, exactly. Like, why do you need that stuff added to your code editor? Like, just no. Go away. Kind of person who in college wrote out music assignments by hand instead of using notation software. Yeah, I mean, that makes sense. I don't know about writing code by hand, but I would imagine if there were a way to do it efficiently, I probably would be doing it. All right. So, let's talk about this as a API for a second. So the general flow is you have this request, you fill it out, then you call kResource system request. You have to pass the system state, which is fine. Most of our systems work that way. And then you have the name of the resource that you are requesting, right? So you have the kname create for that. Again, not really a huge deal. I might think about maybe redoing that a little bit, and maybe just automatically doing this instead of having you have to pass it in that way. But so there's that, and then you pass the request info. Now, I don't think the thing about passing a structure like this, and the reason I did it this way initially, is because if you pass a structure here as opposed to just a bunch of strings or a bunch of bespoke properties, right, or arguments, is if you need to add or modify the arguments to the function, then all you have to do is actually just modify the struct, which is fine. The disadvantage to that is every time you call this, you have to fill out one of those structs, right? Now this, to me, is quite verbose to actually load up something that, is like just to load up a scene. Like I would much rather see an API thinking about it. Like maybe we have this, right? And we still have scene resource, fine, right? But maybe we do, kResource system request, right? And then instead of having all of this, right, we would still probably pass the state. We would maybe just do the name of it, right? So just test scene and convert that to a case string on the fly. And maybe that would be it, right? Like it'd actually be kind of neat to just have that be the API, right? And essentially what this would be is this would essentially just return a pointer to the kResource, as it is, even if it's unloaded, right? So it would return a pointer to the resource, right? No matter what happened, unless this resource request failed for some reason, right? And then it would return a void or a null pointer, right? So that would be the reason you would check for this, right? But I think this would be a lot easier to use, right? And so how would we get from this, right, to this? So I think we probably would get this by, breaking down some of what's going on here. So the first thing we could take a look at is we have this synchronous bit here, right? Which our resource and asset system isn't asynchronous yet, but it will be, and I still intend on adding that. We're going to Jobify that, so I don't want to remove that capability. So the first thing that you might want to think, or that you think that you might want to add in here is like a true or false, right? To say synchronous, true or false. But I would actually argue that instead you should have async, right? Or maybe sync, right? So like this one would default to being asynchronous, this one would default to being synchronous. And maybe one of them calls the other under the hood, right? That already removes a Boolean, which is nice, right? That's one less thing we have to fill out. As far as the type goes, I feel like the type is probably something that we could pass along as an argument and still be okay. I think we could still do, kResource type scene, right? And I think that's still acceptable, right? That's still kind of an acceptable number of arguments, right? So I think that's fine. And that right there basically eliminates this bit. Next, there's this bit about the assets, right? And so I think, one of the reasons that we have the ability to to specify all of this stuff is because the underlying assets for the resource could come from anywhere, and we may have one or we may have many assets required for a particular type of resource. And so I think, in the grand scheme of things, most resources probably aren't going to need this. So when you're loading up a scene, you could probably safely make the assumption that whatever name you provide here is going to also be the name of the asset that you're going to be loading, right? So I think under normal circumstances, or under most circumstances, you could probably completely eliminate that, right? The same could be said if we're loading a texture, right? If you're loading a texture under normal circumstances, that's going to be one image file. There is an exception to that, though. And that exception would be a cube map, right? Which has the capability of taking 6 files, right? 1 per face. And then we also have the other corner case, which would be a layered texture, which can also load multiple textures and then put them into a single layered texture where all those textures are the same size and so forth. And so I think, that is another kind of case where we could have multiple files or multiple assets required for the same resource, right? And so I think in that sense, both of those are textures, right? Those are specific kinds of textures. So what we could realistically do in that case is we could theoretically offload that to the texture manager, the texture handler, right? The texture system, rather. And the texture system would be responsible for maybe coordinating those asset requests and then, manually setting up that resource internally instead of us having to do it via a K resource, right? I feel like that is probably going to be our way around that. There are, if we think about some other different types of resources that we have, right? So actually, let's just go to our listing here. So a text file is just going to be one single asset, right? Binary is going to be one asset. Texture, we've already talked about that. Material is going to be one asset. Shader is going to be... shader is actually going to be 2 assets, right? So let's come back to shader. Static mesh and skeletal mesh. Static mesh is going to be 1 file. But the import process gets a little weird, right? So we'll kind of come back to importing and stuff in a bit. Skeletal mesh is going to be kind of the same way when we get around to that. So then we have bitmap font and system font, scene. These are all single asset resources. Height map terrain. You could argue that that's a you could argue that that's a multiple asset resource, right? Because you've got sort of the terrain configuration file, and then you've got the height map image asset, right? But we could also circumvent that where we have a height map terrain is basically we could probably change that up and probably should change that up so that the height map terrain actually has a binary file format that contains all of the imported height data so that we don't have to import that every single time and calculate it and all that stuff. And so the import process for this would contain multiple assets, but not necessarily the actual loading of the final asset, right? And same could be said for probably voxel terrain, right? So these two could also become single asset, right? Audio is a single asset, right? So really the only things that we have that could be potentially more than one asset is textures and shaders at the end of the day. And yeah, actually that's it, right? Skeletal mesh we can kind of come back to and talk about at another time when we get ready to handle that. So we already came up with our texture, our texture scenario here, right? We can offload those special cases to the texture system and be fine. As far as the shader goes, we also have a shader system that manages our shaders for us. So we could offload the loading of multiple shader assets to that as well. And so I would actually argue, like, some of these things don't even necessarily have to be resource types. A shader probably being one of those things. A shader might not actually have to be a resource type at all. We could probably just move that to being managed by the shader system only, and we only just have, a pointer to a shader, whether it be an opaque type or whatever, and we just deal with that, right? So when we think about all of that put together, we don't really need this, right? Because if we do need more than one asset, we could just coordinate that by the system that's requiring it. And so I think ultimately what that means is that we can actually get down to an API that looks something like this, where both of them will return a pointer to the resource, right? Whether that resource is loaded or not right away depends on a few things, but you can assume that it's loaded if it returns a pointer from request sync. You can assume that it's loaded. If you do the asynchronous request, you should assume that it's not loaded, but you still have a pointer to that resource. So this is kind of what I'm thinking in terms of how we're going to handle the resources. Let me catch up on chat because it looks like we have some stuff here. Okay. Just noticed something in your ZSH plugins section. You add web search but didn't mention the git clone command above. It's not standard. That's possible. There's some holes in it for sure. I haven't actually set it up from scratch in a while, so it's possible I've missed some stuff. Just have different request functions. Yeah, I think that's what we were talking about for this. Yeah. Is it too much to handle the error case of printf? I have a perfection complexity to handle every possible failure. That's what Zig did to me. I feel like there's something missing in my code without doing that. I'm not sure what you mean, to be completely honest. Are you talking about this? Like to just handle this error case? Is that what you mean? Question, why not just have assets? So a texture resource would just be an image asset that is loaded as a resource. A scene resource is just an asset that contains references to multiple assets. So you just have a texture asset, scene asset, terrain asset. No need to divide between assets and resources. So that was one of the things that I was talking about earlier, where we have this divide, and I'm still not 100% sold on it, right? But like, we have this divide between resources and textures. Sorry, resources and assets, because you might have one type of asset that's used for multiple types of resources or has multiple different types of use. So an image asset can be used for a texture, but not only used for a texture, it can also be used for lots of other things within the engine, right? Or within game code or what have you, right? There's lots of different things that you could use it for. So it's not necessarily just that, right? There's not necessarily always a one-to-one, although the most common case is a one-to-one, which would be an argument for getting rid of resources. Let's see. Are you going to support MIDI as a resource? I hadn't considered it. Only because I didn't really have a need, but I mean, it might be an interesting experiment to do, for sure. Ignore that ZSH wasn't updated. It's part of the default ZSH thing. I thought that it probably would be, but I wasn't 100% sure off the top of my head. Thank you for the posture check, by the way. I was probably slouching in my chair, so I appreciate that. Right, but inverting that, will a resource ever use different types of assets? So one of the things that we have in place now that I've also been kind of considering doing away with, for convenience, let me actually pull up, let's pull up an asset list here so that we can actually take a look at an example of exactly what I mean. So let's see, is this, let's start with actually, let's start with images first, and then we'll go to models here in a second. So one of the things that we're doing right now is we actually have a we have an asset manifest, right? And I'm sure you've probably seen this before. Our asset manifest lists out all the assets that we would ever need, right? So it gives it a name so that we can look it up. And then a path to the actual asset, right? So this is, for example, this is our item DB that we just added. Now, if we take a look down here a little bit further, I'll look at a texture. Well, I'll look at this one. So if we look at this texture here, right, this is the name that we would look up the texture by, right? So this is the name of the asset. This is the path to the Kohi binary image. That's the KBI, right? So this is a proprietary format that we have that the game engine reads by default. So our game engine runtime does not deal with PNGs, JPEGs, bitmaps, any of that stuff. We have an import process that converts from whatever that is to this KBI, right? So we have a path that is that KBI, and then we have a source path, which is the PNG or whatever source image it is, right? So we have here our source images, and then we see all these KBIs here that have been imported, right? And so there's an import process that says, within the asset handler itself, it says, take a look at the path. If that path doesn't exist, and we have a source path, then run an importer automatically to import this and create this, right? And our engine does that automatically in debug builds, right? So it won't do that in a release build, but it will do it in a debug build. And so it's been pretty convenient to be able to just do it this way, right? Because we don't actually have like a drag and drop editor where we can just add these things, all at once. And so it's been kind of nice to have this auto import where if it doesn't find this, it'll go ahead and import it, and then you'll have this. The other flip side of that is it makes it very easy for us to update the asset where we could just unload a scene and then, delete this file if this has been updated and just reload it, right? And we actually did have hot reloading working as well through this, right? So we could detect if the source asset's been overridden and, re-import it, rewrite this file, and then tell the engine, hey, this thing's been hot reloaded. So we already have a lot of that stuff in place, and it is super convenient. But there's a lot of complexity behind that, as you might imagine. And so that's one thing that I've kind of been like on the fence about. Do we keep this? Or do we not? Right? Because it is useful for sure. And having the ability to hot reload textures, for example, could be very useful. But it's kind of a pain in the butt to support, right? So like, I'm not sure if we were to get rid of the separation between the two, that would need some rework as well. So I'm not sure if that answers your question or not, but like that's part of where the complexity of that comes from. Orshi, how's it going? Good to see you. Let's see. What should I do? Should I create another project for a level editor which uses the same rendering engine, or should I combine the level editor and main application together? So that's a bit loaded, but I'll tell you how we're going to handle it with this when we get ready to make our level editor. So long-term goal is I'm going to have a freestanding editor. right? That's its own application. However, in the meantime, as we're building the editor tools, I'm going to build it into the game code, but I'm going to kind of keep it separate so that once I have that stuff built, I can actually just pick it up and drop it into a new project afterwards. Don't resources work by taking reference to an asset where a resource defines some behavior to be done in an asset without modifying the original? Yeah, I mean, that's another aspect of it. We don't necessarily do that directly. So the way that images work, for example, is when we load up this asset, we then take the pixel data out of that, we upload it to the GPU, and then we say, okay, now we can release this asset. We don't need it in memory anymore. And so for the most part, that's the way that works, right? And that's the way all of our sort of resources work. All right, so there's that. Now, the slightly more complicated version of this is the static mesh, for example, right? So the static mesh is a little bit more complicated because it takes an OBJ file. The OBJ file references a material file, right? So the whenever we go to import an OBJ to get a Kohi static mesh, we import the OBJ file and we import the MTL file, which is the material library, which might create multiple KMTs, right? And so, there's a little bit of complexity there in terms of actually importing this. So if we were to get rid of the auto import out of the runtime, actually the auto import isn't even in the runtime. It's actually in the debug plugin. But if we were to get rid of that altogether and do it manually, it probably would make things a lot easier to manage in terms of our resource/asset management, right? And so Diamond, you're not completely on the wrong path there at all. In fact, you're not on the wrong path at all. And that was one of the reasons I kind of wanted to start talking about this, is because that is something that very much we could address, right? So instead of having both asset system requests and resources, maybe we only deal with assets, and as far as resources are concerned, maybe we don't have sort of a generic type of resource. Maybe we have a system for each type of resource that is responsible for loading that thing, kind of like our texture system, kind of like our static mesh system, which doesn't really do much right now, but it does actually exist and does kick off some of that loading. And so maybe that's kind of the way we should do it, and maybe we get rid of the resource system and only deal with assets. The other thing, let me go back to this. So this file, this asset manifest, has a couple of different purposes, right? One thing is going to be, this is going to be used to generate a binary package that contains all of these assets in one giant blob, right? And it only contains the primary assets, none of the source, right? And so by having this list, it gives us a list of all the assets that we're going to need for that. It also allows us to access these assets by name, right? So we don't have to point it to some path on disk, right? We could just say, I want the asset called this. And so, theoretically, if we were to get rid of, the source path, the import thing from here, and we say we only deal with, the final sort of assets in here, if we simplify it to that, then we could argue that maybe we don't need this if we figure out a different way to handle the naming of assets, right? So one thing that some other game engines do is, alongside the asset itself, there will be some sort of metadata file that will contain some data, some metadata about that particular asset. Maybe it'll include source path, for example. And then the metadata file will actually be named the name of the asset that you want to reference, right? And so in code, you might have, be referencing itemdb exactly as we have here, and you'd have a file that sits next to it called itemdb, which in this case would be, where do we wind up putting that? I think we actually have it in our tools. Whatever, that's not important. Another way that we could do that is to have that, and then just remove packaging altogether. I don't really like that idea. I kind of like the packaging system that we have. So I kind of think we should probably stick with that, because it does allow us a nice way to package up our assets when we go to actually ship the thing, right? So we don't have a bunch of loose assets sitting on disk. And the other thing that we can do with that is we can actually arrange our assets within that package file so that we can put all assets that are going to be loaded next to each other or need to be loaded kind of at the same time. We can put them next to each other so that they're in contiguous blocks of memory, or they're next to each other so that they're not fragmented all over the place. So that would actually improve our load speed a little bit as well. Let's see, should I re-implement graphics file formats from scratch for learning purposes, or is it a waste of time? When you say graphics file formats, do you mean like PNG and JPEG and stuff like that? Because that is one thing that we actually skipped in this project, is I don't bother with that. Kind of sounds like Fmod audio banks. Kind of, sort of, yeah. It's very similar to that, yeah. It's kind of the same scenario, right? And so, we could accomplish all of that without necessarily having this manifest, but I kind of like having this manifest because this not only gives us a map whenever we load this package to say, here's all the names of the assets that we have and the paths to load them. But it also gives us a blueprint to generate that binary file, which would also have this stuff in it for release build. I did write a PNG parser. Do not recommend. It's very hard. Not worth the time. It's a solved problem. I tend to agree. I wrote a Targa loader a while back, and yeah, it's a pain in the butt. Because then you have all the different sort of sub formats within that encoding algorithm that you have to worry about too, and all the different flags and all that stuff. It's usually not really worth it. As far as image formats go, yeah, I would say audio formats is very much the same thing. Image formats, audio formats, and reading font files. Those are the three things that we actually I don't do from scratch. Not really worth it. Okay. So, we have that. So that's kind of what I'm thinking there, is it would be really nice maybe to not even have to worry about packages, right? Because like that was the other thing I wanted to kind of talk about too, is we always have to fill out this package name here, right? I think that if we manage our packages correctly, right, we shouldn't even really have to do this at all, right? And something that I tried before that didn't really work out so well is, I did try, doing that basically is the asset name, right? Where you would have, package name dot something, right? The problem is dot is also used for file extensions, and so if you don't do this correctly and you name your file really weird things, trying to find the extension sometimes gets a little bit weird, especially if it's a multi-dot extension. And so I don't generally recommend doing it that way either. So in terms of package name go, as far as package name, I'm actually kind of considering doing away with multiple packages. As much as I like that idea, I'm kind of thinking about rolling that back. So when I say multiple packages, what we have is, if we take a look at the Kohi submodules, we have a couple of different libraries here, core libraries, right? So we have runtime is one of them, right? And some of these things actually come with assets of their own. So the core runtime package actually has fonts, images, right, and some shaders. And so I think it's probably it's kind of nice to be able to include like base engine assets this way, which is one of the reasons I did it. But the problem with that is that whenever you go to request an asset, you have to provide a package name, because that same name asset could exist in more than one package, which is kind of poop, if we're honest. And so I'd like to think of a better way to handle this rather than having to have multiple packages, right? So like maybe, maybe the assets that are included with Kohi are all sort of rolled into like a Kohi assets folder, and those assets automatically get rolled into your asset manifest that goes along with your actual game library, right? And then you're just dealing with one package. I think that would be a lot easier to use, and you don't have to worry about naming, right? Because if you go to name, if you go to include a asset that is already kind of included by the base, then it's going to scream at you and say, hey, you got to name it something else because it already exists, right? And so that was something that I kind of have been thinking about too. I don't know exactly where I'm going to land on that, but that was kind of another thing that I was thinking about. So there's that. And then if we were to go with the idea of just having assets only, which is another thing I kind of wanted to talk about as well. This is going to be no check-in. We'll have notes. This would be the new resource system API if we go this route. And then down here, we would have something similar. So no check-in, and then note, if we go the asset only route, this is the API for that, right? And so this kind of looks similar to what we have up here for resources. The only difference being is that this has a return type of void, right? So we don't necessarily want to do that. So what we would really want to do is we'd want to have, let's see, so we'll do asset states, and then instead of info, we would probably just want to do something like item DB. And then instead of relying on this callback and all this kind of stuff, right? And maybe we still allow one, right? We would do k-asset, actually I think it's k-asset binary. It would look something like this, right? So we would, again, just like this system does, we would immediately return a pointer to that specific asset. And then, check against that to see if it exists. And if it doesn't, throw an error, blah, 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 right? So it would do this. Right? Item DB asset, right? And so instead of having all this stuff, you'd have this, and then like we've discussed before, we would also have a synchronous version of it, right? To eliminate this guy, right? And then again, we might have for the asset type, just to say, this is how we should process or treat the asset. Right? And so we'd have something that looked like that, right? Let me just move this over. Actually, I can close that one. Right, and so you wouldn't need this at all. All you would need would be this. That would be your new API. And I think there's a lot that could be said for this, right? So, you probably wouldn't want to load every type of resource this way, right? But it gives you the access to be able to load binary assets this way. If you wanted to load something like a texture, you'd load that through the texture system. If you wanted to load a font, you'd load that through the font system. You generally wouldn't want to directly load an asset like this unless there's something very specific like this for the item DB that you want to do. But you could if you wanted to, right? You could do the same thing for images. And so I think this is actually probably a really good way to do it. The question is, what do we do about packages, right? And that exists for both of these options, right? Because either way, we don't really want to have to overthink about what package this is coming from, right? So either we eliminate packages entirely, or we figure out some sort of better way to actually reference those. One thing I don't want to have to do is I don't want another parameter here where I have to say, testbed is the package name, and then this, right? I don't want to have to do this. Because that's extremely error prone, for one thing. But then also, it's just another property that you have to pass in everywhere, which I think is unnecessary. So I really want to focus on, making the API for this as lean and mean as possible, and going from there. So I think in either scenario, by the way, we would probably also want to have, for the asynchronous version, we'd want to have, some sort of callback, right? So, resource loaded callback, and then, asset loaded callback, right? And then for the synchronous version, you wouldn't need that callback, right? So I think that probably does make sense, right? So since this is asynchronous, we want to be notified of when this is actually loaded. I think that's totally fine. The synchronous version doesn't need that. You could just process it directly afterwards. Either way, you can check for the existence of a pointer because we should get that either way, right? Okay. So I guess that's the last piece of this is what do we do about packages? Do we, because here's the thing, if we say we require packages, if we say we require the package name, then we don't have to touch package management at all, right? It could just work as it is. We don't have to touch the asset manifest. We don't have to touch any of that stuff. If we say that we don't want to require packages or package information, then we do have to touch that stuff. To make it so that it's only one package that we reference. There is a third option, now that I think about it. We could also have another set of functions. Right, and we'll do the resource version first. We could have a request from package. Right, and then request from package sync. Right, where we do say package name. right? And again, that eliminates us from having to pass package name all the time. And, allows us to say, we only want to request from package when we're specifically loading from a different package that's not the game, right? So if we're loading a game package or something out of our application package, then we would want to use this one, right? Because this would just default to using whatever the game package is, right? So this would be what you'd use 99% of the time. And then for loading prepackaged stuff that comes like runtime resources or whatever, if you want to explicitly load it from package, you would just do this. And I think that makes sense. And that would be my cat sneezing in the background. All right. So, actually, yeah, she has allergies just like me. It's wonderful. Yeah, I have to actually give her allergy medications just like me too. That's always fun. If you can imagine trying to give allergy medications to a cat. She is not a fan, put it that way. All right, so we could very easily just do this. And the advantage that this has is this allows us to meet both the requirements of having a simplified API and not have to touch our package system now, right? We could offload that to the future. And then if in the future we decided to do away with the packaging system that we have and we want to change that up, we could do that. And so this would mostly just give us essentially the API level change, and that would be basically it, right? So I guess the real question is the only real thing we have to do is choose whether we want to go this way or this way, right? Do we want to have the resource system request, or do we want to have just assets? That's going to be... It sounds like me when I sneeze. Antihistamines? Yeah, exactly. It sounds like a hiss when she sneezes. For sure. First time chatter, United Universe. Welcome. All right. Okay. So actually we can eliminate the packages question. I guess the real question is, which route do we want to go? Do we want to say assets only? Right, because if we think about the one-to-many relationship that we could potentially have with resources, it's really only a couple of types that have that. And those types could be offset to their respective systems. So all of these resource types have this sort of base structure, right, of a resource that contains type, state, whether it's loaded or not, generation, tag count, all this stuff. I think, and the more I think about this, the more I actually am kind of liking and leaning towards getting rid of resources. Because when we start to think about, resources and assets are for the most part one-to-one, with the exception of the exception cases we've already talked about, I think it does make a lot more sense to only have one level of those things, right? So while I'm pretty happy with the way that the resource system came out, I think it was a good thing. It was a good learning exercise for us to try it that way. I think we probably... Because here was another issue with this. and this is something I've been meaning to fix for quite some time. K resource system release actually released by name, right? Which isn't great because you generally had a pointer to the resource anywhere and anyways, right? So this then had to like look up the resource internally by name and then free that pointer, but then you've got this other pointer out here that was just still dangling anyways, right? So I think that's something that would go away completely with this as well. Okay, yeah, I think this is, I think I'm gonna try and go, I think I'm gonna try and go this way. So we might keep some things like named, you know, K-resource scene or K-resource texture. At least until we have, at least until we've actually removed that system. And then we can rename them across the code base. Like K-resource texture would just become K-texture. All right, so I guess we're doing all this in testbed main, which is actually not great. So I suppose we should probably move this to somewhere where we have notes, right? So let's actually just get rid of, we're not going to do this version. We are going to take in, we're going to do this one. So let's go to to-do. And, oh, I forgot to remove this one. Shoot. Okay. Let me actually do we still have the retrospective notes? We do. Okay. So I guess I could put it, we'll say to-do list, and then we'll say 0.10. And I'll paste all this stuff down here for reference, right? So the to-do list for version 10, is going to be removal of the resource system in general. Offload resource handler logic to bespoke systems per resource type. Assets will be the only system left with the API looking like the below reference. This is pretty self-explanatory about how all this is going to work. So we don't have to change anything with packaging. We don't have to change anything at... Oh, the only thing we're going to have to think about is auto imports and hot reloading. We're going to have to think about those too. I'm okay with not having those working in the short term if it means that we can get this API, right? And then we can just kind of work. We could work on that after the fact, right? We could very easily use our event system for that, to just say, listen for a asset hot reloaded message, and if the asset type comes through as image or something like that, then our texture manager, our texture system could be listening for that and say, okay, well, we've got a texture that hot reloaded here, an image resource that's called this, that hot reloaded. Look that up in our texture system, look up that texture and reload it, right? And I think that's a reasonable approach, right? So that would be systems can register for a KS at hot reloaded event and handle it thusly. So that actually hot reloading is not going to be too difficult at all to handle at that level. Easier than it actually is now. Auto imports gets a little bit trickier. So we may... I'm really tempted to do away with auto imports. I'm really tempted to just like move that to an external tool set and just make it be like a tool that we have to run. Maybe we feed that tool the asset manifest and just have the asset manifest just go through and do all of it, right? Ooh, that's actually a good idea. Externalize to a tool that reads the asset manifest and imports and performs all imports of assets within it. I like that better because then we can actually eliminate all of that complexity out as well. And then as far as hot reloading goes, we only support that for certain types of assets anyways. That was always kind of the plan. I think anything that's past, like an image was updated, so hot reload the texture. Anything that's past that sort of level of complexity, we're just not going to bother with. So like for example, an OBJ file that has a material file with it, or a GLTF when we get around to that. I think anything like that, we're just not going to hot reload for now. Maybe we add it in the future, but I feel like externalizing that is an acceptable solution. And then if we go to load the primary asset in the game logic and it's not there, we just bleat about it and say, hey, run this program to import your assets, you dingus. And then that will be the end of it. Okay. So I think that is probably what we need to do. I think that's probably inclusive of everything we need to do, which doesn't sound like a lot. It is a lot, but not the end of the world. So our entire asset system will essentially be that. Well, and a release. All right, so you'd also have, assets, system, release, asset. Engine systems gets, something like that, right? When you go to release, that's essentially all you would have to do. I think that makes sense. The only other thing that I can think of, if we wanted to split this out further, we could, in theory, and I don't really like this idea as much, we do have this asset type here, right, which essentially is just going to call a switch internally. We could have asset system request binary, asset system request image, asset system request static mesh, and return the actual asset types for each one of those things instead of having it generic like this. Because you would have to know this binary type or I should say this asset type here, and to know to cast it here, which is not great. So we could do, just brainstorming here, could do this per asset type, right? So we would have asset system request binary, right? And then we wouldn't need this. We would only need essentially this. And then we could have, you know, the sync version of that without the callback. And then, you know, the from package version of that. Now, the problem with this is, the problem with this is this becomes kind of verbose, right? Oh, I forgot to put package name. Not verbose, I guess, is not the word I look for. I'm looking for. It's there's a lot of functions if we go this route, right? Because essentially we'd have to have these 4 functions for every single type. It is less typing when you go to use it, though. Well, it is and it isn't, I guess. You know, instead of typing, well, actually, yeah, it would be less typing because all of these, you would really have to do this. You would have to hardcast that. And also, you would also have to look at, you know, a switch statement here to figure out how much memory you need to actually allocate, because a K asset, a base K asset, is not the same as a K asset binary. Obviously, release would have to do that same kind of thing, but like at that point, this would also always, this would also always be, when we go to release, it would also be, you'd also have to do that, which is not a huge deal. Forgot a colon. Yeah, I'm sure I did. I am sure I did. Which is fine. This is just, I mean, this is kind of pseudocode anyways. Oh, the package name. Yep, you're right. I see it. Yeah. Yeah, this is just pseudocode anyways, but yeah, thank you. So I guess, you know, in terms of API design, these are our 2 options. We could go this way, the sort of super generic version, and then have to cast all the time. Or we could go this way. Since we know what the types are anyways, this actually does kind of make sense. We're going to wind up with a lot of shared logic between these, but that could just be private static functions that we call. I'm actually kind of leaning more towards this one, now that I think about it. Yeah, you would do the second one. I'm kind of leaning more towards that one too. Because we know the types that we're going to have, right? And like, the only time we would ever need this, if we did that, the only time we would ever need this is when we go to release it. And I could even argue that we could even have, you know, a specialized release as well. It's a little bit more type safe as well. So we could do, you know, I guess it would be that, right? That's a lot more explicit. Feels cleaner too. Yeah, I'm actually kind of leaning towards this one. Because I think, yes, we'll have more functions, but I think that's okay. I mean, even if you were doing this the C++ OOPI way, you'd have all those functions anyways, right? So, like, there's not really that much of a difference. The other thing that this would allow us to do, actually, is we could completely eliminate this. We wouldn't even need to know the asset type. We wouldn't have to pass the asset type anywhere. We wouldn't even need that enumeration at all, I don't think, if we went specifically this direction, because we always know the type. I think we have just made our decision. I think this is the way we're going to go. All right, so we have our to-do list. We know what we're going to do for this next release. This release 0.10 is only going to include this, oops, crap, this change here. So it's only going to include this stuff. And then we're going to cut that version. And once we've done that, it's going to make actually the rework of scenes easier as well. Because that was one thing that I was kind of like, scenes also has like 2 different parsers currently. So we're going to like scoop all that stuff out and completely throw it away and rewrite it. And then the render graph stuff is kind of separate from this. So maybe we'll do, I don't know which one of those I'm going to do next. I'll have to think about it. But I think this is the route we're going to head. In C++, you'd have a release for every type. Yeah, I mean, that's sort of the C++ way of doing it, right? And I'm actually thinking, let's just do that, right? Let's just have a release for every single type as well. Because then it gets sort of, we can also get rid of this sort of weird structure hierarchy that we have here as well that we don't really need if we go this route. All right. So I think that is going to do it for tonight's stream. We actually have a game plan going forward. I kind of enjoyed doing this retrospective. It was kind of neat to kind of zoom back and take a look at things and think about what we need to do going forward. So we're going to tackle this on the next stream starting tomorrow. And let's see. If this was Zig, you could have comp time static dispatch. Yeah, I know. I'm not doing Zig. Not doing it. Okay, so I'm going to look for somebody to raid. While I do that, if you haven't already, I would greatly appreciate a follow. Either on the Twitch side or the YouTube side, because I'm trying to grow the channel and encourage more people to learn how to actually make, lower level game engine tech, because we need more competition in this space, and I'm hoping to get more people into it. So that hopefully they can go out there and write great things and make it better for us all. So if this kind of thing interests you, please do give me a follow. I would greatly appreciate it. And let me see. Let me see who is on that I can raid. Hoping to find something that's kind of related to what we're doing. Just bear with me here for a moment. I already have an idea of what we're going to do if I don't find what I'm looking for specifically. All right. All right. We are going to go check out. Let's see, which one do I want to do? We're going to go check out Jitspo. He's making a retro FPS using Godot. Not sure. Looks like he's doing texturing and animation, so we'll have to see what he's up to. But yeah, anyways, thank you guys so much for being here. I appreciate you guys, and I will see you guys in the next stream, which is tomorrow night, starting at 9 Eastern. So I'll see you guys later.